Hello, dear student. So let's start our lecture. And we have just covered these topics yesterday in Inverse Trigonometric Function of class 12. So this is like basically covering your NCERT portion of class 12 maths. And this is your second chapter of maths. And it is Inverse Trigonometric Functions. So yeah, in the previous lecture, we have just seen the examples of like exercise questions. So we will continue our discussion after that. So we have covered the fifth question, and now we will see sixth one is easier. We will solve like this is also seventh one is also similar to like fifth one. We will solve eighth one. Let's try to solve this question. So here you have tan inverse cos x minus sin x upon cos x plus sin x. Okay. So yeah. Uh, if you see here, so what can you infer from this? So how can you solve this question if like you have to simplify this question? So how can you do that? One method is that I can like multiply by the conjugate inside the bracket. So I can simplify that also. Let's do something so that we can just simplify it. Okay. So just multiply it like and write it like tan inverse cos x minus sin x. Okay. Bonds. Yes. Okay. Uh, cos x plus sin x. Just well, do one thing and you divide it both numerator and denominator by what? By your sin x. Okay. So I will divide it by like no cos x. Okay. Cos x divided by cos x. So I will divide numerator denominator by cos x only. Yes. So here also cos x and here also cos x. One way is doing by this. You can multiply with conjugate method. That will be also okay. But let's find out the answer in the easiest way. So this will become inside the bracket as 1 minus tan x upon 1 plus tan x. Okay. Now recall the your formula for tan a plus a minus b. Tan a minus b. That is equal to tan a minus tan b upon 1 plus tan a into tan b. So you can like see that there is some like similarity to that your formula. So you can write it like this: tan inverse into tan of, here you can write it like what? Pi by 4 minus x. Why it's so? Because if you expand this whole function, you will get what? Tan a, that is tan pi by 4 minus tan x upon 1 plus tan pi by 4 into tan x. And this will simplify to 1 minus tan x upon 1 plus tan x. Because tan pi by 4 is 1. So that is why the relation is coming like this. And now you can just cancel out your tan and tan inverse like that. So the final answer will be what? Pi by 4 minus x. So this is your final answer. I hope that you got this question. Here, your x is also belonging to 0 to 1. Okay. Let's move further and see the next question. So I will delete the drawings here. Now just move forward. The ninth question is like tan inverse x upon root a square minus x square. So this also you can do by yourself. It is very simple. Just substitute x is equal to what? x you can substitute as a cos x. Okay, a cos theta or a cos like any angle. So you just substitute that, you will get the answer. So I hope that you can do this by yourself. Let's move to the next question. So here the 10th question is saying that tan inverse 3a square x minus x2 upon a cube minus 3a x square. Let's do this question. So we have like, let's assume this y equal to tan inverse 3a square x minus x cube upon a cube minus 3ax square. Okay, now you have to just simplify this function. So how to do this, like what substitution you can like do here? Yeah, so you can substitute here like x is equal to what? If you like substitute here uh, like x is equal to x cos theta or sin theta, you can like assume if the it can be solved easily. Okay, so let's find out that how it will be solved. So I will substitute here x is equal to like your sin theta. Okay, yes, sin theta. So what will be the result of this? And also here should be one thing also there. That is what? That should be your a sin theta. Okay, so let's substitute that. So y will become tan inverse 3a cube sin theta. Okay, and here what will be the another thing? That will be a cube sin cube theta. Yes, the denominator part, what will be that? So that will be equal to a cube minus 3a and cube sine square theta, like that. So you will get like that thing. Okay, okay, now okay, you can also do one thing, that if you just take common here. So I will do one another shortcut method. It will become some lengthy method. So I will do one thing, that I will take common some terms from denominator and numerator in the like inside part. Let's do that also. So if I take it like y equal to tan inverse, and here I should take 3a like x common, so it will become 3a square minus x square. Okay, inside this. And in the denominator part, what will be remaining? Like you take a common, so here it will become a square minus 3 and x square. Okay, like this. So you have like these terms in the like inside of tan inverse. Okay. So what can you do now? So you have the formula like sine 3 theta is equal to 3 sine theta. Okay, minus yes, 4 sine cube theta. This formula you have. And also one formula for you is that cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. So you can use these formulas also. So yeah, let's do that also here. So that will be easier to you for solving. And let's do that also here. So I will just do one thing, that I will substitute again it, because it will become here 11. So I will do that method also. Okay. So yes, what to y will become here? Yes. So y will become what here? Y is equal to tan inverse, and substitute here x is equal to your like a sine theta, which I have already substituted before. So it will become 3 a cube sine theta minus a cube sine cube theta. Okay, this is clear for you. Okay, and the denominator part, what will be there? A cube minus 3, and this will become your a cube sine square theta. Yes. Now a cube and a cube will be cancelled out in the numerator and denominator part. So inside what will be remaining? Y is equal to tan inverse, uh, like your 3 sine theta minus 6 sine cube theta. Okay, and now in the denominator part you have 1 minus 3 sine square theta. Okay, so and you can see that this is like not giving any relation, but if you have substituted it like x is equal to your a tan theta, then it will give you some relation that will become like tan theta formula. So just substitute here your like theta x is equal to a tan theta. So we will do that only. So we will get the result. Okay. So here I will place tan theta only. So I will get the result. Just do this. Yes. So here just substitute tan theta. So you will get the result. It will become tan theta minus a cube tan cube theta. And here also 3a cube tan square theta. Now it will be clear to you that it is becoming tan 3 theta inside. It will come as tan inverse. A cube will cancel out in the both numerator and denominator. It will come as 3 tan theta minus tan cube theta upon what? 1 minus 3 tan square theta. Inside this is what? This is your only tan 3 theta. So it will become tan inverse tan 3 theta. Tan and tan inverse will cancel out. It will give you 3 theta. What is theta here? Theta is here like a tan theta. So theta is here what? X by a, and it tan inverse also. So tan inverse x by a. So it will come as 3 tan inverse x by a. This is your answer. Okay, for this question. So it was a good question, and this is the final answer. We have just substituted x is equal to a tan theta. So you just be careful that what should be the like substitution for each question, so you can easily get the answer. Okay, let's move to the next question and see that what is next. Let's see. So see the 11th question. It is also a very good question. So let's find out. So here given that what is the value of tan inverse 2 cos into 2 sine inverse 1 by 2. Okay. So if you have just like functions like this that are containing 2 or more functions inside them, so we'll do one thing that convert the inside one, which is like inside this last bracket, convert it into your what? Some like sine inverse is there, so you should convert it into cos inverse. So you can get the result. Okay. So let's do this. Yes. So what is the formula of 2 sine inverse x? If you have like 2 sine inverse x, so you will get it like if here is tan inverse 2 cos, and this is inside 2 sine inverse 1 by 2. Okay. Yes. This is the function, and you have to find out the value of like 2 sine inverse 1 by 2. So apply it like sine inverse 2 sine inverse x. 2 sine inverse x. What is the formula of this? Formula of this is 2, and your like here is sine inverse x and cos inverse 1 minus x. What is there? Root 1 minus x square. Okay, this is your formula. So let's do that and find out the result. Okay, let's do that and find out the result. So we'll see that yes, this is the formula for your 2 sine inverse x. Okay, see here, this is the formula. Like yeah, just a second. I have written it not correctly. It is like your 2 sine inverse formula is like what? Here you can see this is equal to sine inverse 2x into root 1 minus x square. Okay. So we have already proved this also. 2 sine inverse x is what? Sine inverse 2x into root 1 minus x square. So you have to apply this formula and then you can simplify this result. Okay. And what x value is what? 1 by 2. So substitute x in like in place of x, you can substitute 1 by 2. It will become tan inverse inside 2 cos and 2 sine inverse will be what? Sine inverse into 2x. 2 into 1 by 2 into root over 1 minus 1 by 4. Okay. So now simplifying further it will become tan inverse 2 cos sine inverse. This will be 1 into root 3 by 4. It will be root 3 by 2 only. Okay. Now just yeah, you can also do it like this. Tan inverse 2 cos. Okay. And here is what? Like it is sine inverse root 3 by 2. So you have the value of sine theta in this triangle as root 3 by 2. Root 3 by 2. It is your root 3. This is 2. It will be what? This side will be what? 1 only. So your cos theta will be half here. Okay. So substitute here like you can write it like cos inverse 1 by 2. Okay. So you can write it like this also. Now cos and cos inverse are there in between. So they will cancel out and we will be remaining with what? It will be tan inverse. Inside it will be what? 2 cos inverse 1 by 2. Okay. So yes. What is the formula of your 2 cos inverse x? That is sin inverse 2x into root 1 minus x square. Okay. So you can either apply that formula. Just you can apply that formula also. So apply here. It will become sin inverse inside what? 2x. What is the like value of 2x here? So 2 into cos inverse 1 by 2. Okay, and what is the value of cos inverse 1 by 2? You can also like substitute the value of cos inverse 1 by 2 inside. So yeah, let's do that also. So I will like make it more simpler. Okay. So it will become what? Tan inverse 2 cos inverse 1 by 2 is what? It will be your pi by 3. So it is coming out to be 2 cos pi by 3. Now tan inverse 2 cos pi by 3 what? And this will be 2 into cos pi 3 value is 1 by 2. So tan inverse 1 is what? pi by 4. So this is your final answer, pi by 4. I hope that you got this question. It was also a good question. So let's remove this question also. I solved it for you. Okay. Let's move further and see that what is the next. So in like next part, you have 12th question is easy for you, so you can solve it by yourself. Now 13th question, you can see it is very like lengthy, but it is also very simple. Just substitute x is equal to tan theta and y is equal to tan theta here. You will get the result. If sine inverse 1 by 5 plus cos inverse of x is equal to 1, then find the value of x. So this is also a simpler question, but I can solve it for you. Let's see the 14th question. Okay, let's solve it. So here you have sine inverse 1 by 5 plus cos inverse x is equal to 1. So I can write 1 as sine pi by 2 also. Okay, you can write it like this also. If you like assume it like this, so you can write it like this also. Okay, so from here you can get the result. Okay, because you see, if you take inverse here both sides, so sine inverse 1 will come with this side, and sine inverse 1 is what? In the principal value, it is what? Principal range, it is pi by 2. That is why I have written here pi by 2. So now solve it. Sine inverse 1 by 5 plus cos inverse x is coming out to be equal to pi by 2. So you already know that whenever sine inverse theta plus cos, sine inverse x plus cos inverse x is pi by 2. So this result you can apply here. So cos inverse x will be equal to what? Cos inverse 1 by 5 only. Because here sine inverse 1 by 5 plus cos inverse 1 by 5 must be equal to pi by 2. So what is the value of x here? 1 by 5. I hope you got it. You see also a simpler example. Now move forward and see what is the next. 50th example is also easy one. So I hope that you can solve it by yourself. Here you have to just apply the triangle law, as you can make by triangle and see the result. Find the values of each of the following expression in this. This is also a very simple one exercise. I think that you can solve these all questions by yourself, and I have like done very much questions for you. So yes. To see the example 9, these are miscellaneous examples. We will see one by one that if the examples are good or not for you. So let's move further and see the examples. Okay. So find the value of sine inverse sine 3 pi by 5. So we know that sine inverse of sine x is always equal to what? X. Therefore, sine inverse sine 3 pi by 5 is equal to 3 pi by 5. But what is the mistake here? 3 pi by 5 is not in the interval of minus pi by 2 to pi by 2. That is the principal range of sine inverse. So we have to convert it into this range value. That will be the principal branch of sine inverse x. Sine 3 pi by 5, we can write it like tan pi by 3 pi by 5. Why we can write it like this? Because this will come in second quadrant, and second quadrant sine is positive. So that is why we can write sine 3 pi by 5 as sine pi minus 3 pi by 5. Okay. Now just do one thing, that we can write it like sine 2 pi by 5, and 2 pi by 5 belongs to minus pi by 2 to pi by 2 interval. You will get sine inverse sine 3 pi by 5 as sine inverse sine 2 pi by 5, and 2 pi by 5 will mean after the calculation. So this is the result. Now the example 10 is sine inverse 3 by 5. We have to show that sine inverse 3 by 5 minus sine inverse 8 by 17 is equal to cos inverse 84 by 85. So how to do this type of questions? You can apply what? Here you can apply the like your formulas of sine inverse A plus sine minus sine inverse Y. Okay. So see here sine x is here 3 by 5 and sine y is 8 by 17. But we have to form the result in cos inverse. So I will find here cos x that will be equal to 4 by 5 because cos x will be root 1 minus sin x square sine square x and that will be equal to root 1 minus 9 by 25. Now we will get it equal to 4 by 5. Why I have taken positive value 4 by 5? We haven't taken minus 4 by 5? You can think of this that why we have not taken minus 4 by 5 here. Because if we take minus 4 by 5, then the result will be not valid. It will not fall in the principal range of cos inverse. Cos inverse has a principal range 0 to pi only. But if you take negative value, it will not fall in this interval. Okay. So just take the positive values of your cos x 4 by 5 and cos y is coming out to be 15 by 17. We have cos x minus y equal to cos x cos y plus sin x sin y. Apply that formula, you will get 4 by 5 into 5 15 by 17 plus 3 by 5 into 18 by 8 by 17. That will come out to be 84 by 85. And if you now find out x minus y, that will be equal to cos inverse 84 by 85. That is the value of sin inverse 3 by 5 minus sin inverse 8 by 17, because x is that and y is that. So we have got the result. Our LHS equal to RHS. Okay. Let's move further and see what is the next topic. There is one more example and I hope that you can solve it by yourself, because it is similar to what we have just like solved. Just see it once, you will get the result. Okay. Yeah. So I should like explain you this example 11 also. It is a good one. So let's solve this also. We have to show that sin inverse 12 by 13 plus cos inverse 4 by 5 plus tan inverse 63 by 16 is equal to pi. Okay, good question. So assume it sin inverse 12 by 13 is equal to x, cos inverse 4 by 5 is equal to y, and tan inverse 63 by 16 is equal to z. Now sin x will become 12 by 13, cos y will become 4 by 5, and tan z will become 63 by 16. Therefore, we have cos x equal to what? Sin x is 12 by 13, so cos x will be 5 by 13 by triangle, making the triangle. Okay, these are Pythagoras triplet 12, 13, 5. So that is why we get the 5 by 13. Similarly, 4 by 5, we got sin y as 3 by 5. Tan z is 63 by 16, so tan x will be what? Here cos x is 5 by 13, so tan x will be 12 by 5 and tan y will be 3 by 4. Okay. Now we have the formula of tan x plus y is equal to tan x plus tan y upon 1 minus tan x into tan y. Apply that formula, you will get tan x plus tan x plus y is equal to minus 63 by 16. Okay, the value is coming like minus 63 by 16 only. Now further solve it and see that what is the result. So after after simplifying it, you will get like tan x plus y is equal to minus of tan z, because 63 by 16 is what? It is minus of tan z only. Here see you can see that tan z is equal to 60 by 16. So it is equal to minus tan of z only. So tan x plus y is coming out to be equal to tan of minus z, because tan of minus z is equal to minus tan z. Or tan x plus y can be written as tan pi minus z, because tan pi minus z will give you the value tan minus z only. So you can write x plus y is equal to minus z or x plus y is equal to pi minus z. So hence since x, y and z are positive, x plus y is not equal to minus z, because x, y and z are all positive here. So x plus y cannot be equal to minus z, because if you take here positive values of x plus y and z is also positive. So minus z will become negative, but x plus y is positive. So positive equal to negative is contradiction. That is why x plus y is not equal to like that here. Okay, here is this statement is wrong. This one is wrong statement. So we will take x plus y is equal to pi minus z, or it will give you x plus y plus z is equal to pi. So that will give you sine inverse 12 by 13 plus cos inverse 4 by 5 plus tan inverse 63 by 16 equal to pi, because x value is this, y value is this, and z value is this. We have already seen. So I hope that you got the question. For the good question and some concepts were there. So this was the end of your like, this is coming to end of the chapter, and we will see the miscellaneous exercise for this. This example is also like you can solve it by yourself also, because it is substitution by substitution method, and you can like take common here by dividing it by b cos x, and then applying tan inverse a by b minus tan inverse tan x, then tan inverse a by b minus x into that. Okay, so let's solve like example 13 then, and then we will like end this discussion and see the exercise in the next class, because due to some time constraints we will end our chapter like this lesson today by this exercise question or example question. So yes, let's see this. So we have given that solve tan inverse 2x plus tan inverse 3x equal to pi by 4. Okay. So what can you do here? You can do one thing, that apply the tan inverse x plus tan inverse y formula. So just applying that, what we will get, tan inverse x plus y, that is 2x plus 3x upon 1 minus 2x into 3x. Okay, is equal to pi by 4. I hope you got this. Now just like take solve further and add the like term. 5x will become in the numerator, and here it will become 1 minus 6x square, and it will come equal to pi by 4. Okay, uh, 10 pi by 4, because tan inverse will come here, so it will become 10 pi by 4, that is equal to 1. Yes, now 6 cross multiply it, like you can do it like this, 6x square plus 5x minus 1 is equal to 0. Just what you have done, you have multiplied it by taking it in right hand side, then you have taken all the terms in the left hand side, so that will come like this only. So it will be simplified by splitting the middle term, 6x minus 1, x plus 1 is equal to 0. X will be here 1 by 6, or x 1 by 6, or x minus 1 only. So if whether the results are like satisfying the original equation or not, we will see also that, then we will answer the question like if the answer is correct or not. So we since x is equal to minus 1 does not satisfy the equation, because x minus 1 is not satisfying the equation here. You can see here, if you substitute x is equal to minus 1 here, so what will it come? See here, tan inverse, like it will come like 5 into minus 1 upon 1 minus 6 into 1. Okay, so in the like your numerator it is coming negative, but you should not have that like numerator in negative form. Why? Because I already told you that tan inverse x is different from tan inverse minus x. In the numerator part, minus should not be there. So your equation is not satisfying by x equal to minus 1 does not satisfy. Okay, because LHS becomes negative. Okay, that is I was telling. So here x equal to 1 by 6 is the only solution, because x equal to 1 by 6 will give you the positive value inside this bracket. That is why x equal to 1 by 6 is your only solution. So I hope that you got this question. Be careful after solving the equation. Like if you have tan inverse x plus tan inverse x term, any other x term, so after like getting, if you get quadratic equation and you're getting x values like 2 values or 3 values, so just substitute that x value. If that x value is giving you negative value, then discard that x value and only take the x value which are satisfying the equation and are positive values, that are giving positive values inside this. Okay, so be careful by solving. I hope that you liked today's session, and I also like assume that you like enjoyed today's session, and you understood what I have told you. So this was enough for today's session, and we will see the further discussion in the next session. If you have any kind of doubt or any kind of suggestion, you can post in the comment box. And if you want like private session or one-to-one session with us, you can then also comment or like ask with us. So this was like enough for today. Thank you and have a great day.